Welcome to class number 3 of our course Strength of Materials. Question number 4. First class I solved a question, that was question number 1. In the second class, first class I gave one homework also, that was question number 2 I told. Previous class I solved one question number 3. You maintain correct order if you want systematically study. Question number 4 written. Now onwards, remember, for a few classes I will be compelled to write before recording because board is little smaller. I am outside Bangalore. I am actually in my native place. So little smaller board. So I have to adjust the space. So maximum I will write and then explain. Unless there is something very important which I will write in front of you only. Anyway, as long as I explain thoroughly and you understand, it hardly matters. See, a steel pipe of length 75 cm is required to support an axial load of 80 kN. Maybe there is a steel pipe here. See, you have seen pipes vertically placed. You can place horizontally also. See, maybe something like this. This is not circular, this is rectangular. See, circular. This way nobody will use it for placing the load, usually like this. And one more thing, in the question it is not given whether tension compression, but see the limitation there, contraction maintained, written. When they wrote contraction there, it is crystal clear that member is in compression. So it will be like this. So this is a pipe here, apply load of 80 kN, length 75 cm. Usually centimeter we don't write, 750 mm. If I take the cross section, you can see a hollow circular section. See, one diameter is D1, other diameter is D2, thickness is T. What they want in the question is, find the required thickness. Thickness you have to find. If outer diameter is 100 mm, when contraction limited to 0.17. Now I will add one thing, full stop. See, extra portion I will add. What will be the stress? What will then? Okay. What will then be the stress? Stress. See, last time stress condition. Then they told what will then be the elongation. Now, change in length condition, that is last time sigma stress condition, what will then be delta. Now, delta condition, what will then be the stress? Say same way, other way question. Okay. Now, one small important you have to write here. See, I wrote D100 outer diameter given. You can write here, this is given. Now, thickness they want, but no, don't go for thickness. You go for inner diameter. Because thickness will come later. After this question is over, I will explain that one. Time being, just imagine, not imagine, time being, what I tell you follow. So, see, first one more thing, D100 mm. So, no need of writing. Still you write if you want here. See, given, actually not required. Outer diameter, say, symbol, D1 is 100 mm. I already wrote, let T be the required thickness. Let D2 be inner diameter. Okay, write that way. Thickness later. Start. So therefore, this question now, what will happen? P is 80 kilonewton, 80, 10 to the power 3 Newton, compression. Length L is 750 mm. E given 200 GPa, 200, 10 to the power 3 MPa, that is Newton per mm square. Last time or first class, second class, crystal clear explained. Someone may tell, he wrote GPa without explaining, he wrote Newton per mm square. What without explaining? How much I explained there? My class is meant for those who start from class 1, thoroughly understand, make a note, study it repeatedly, everything clear. Class 2, that then class 3. Only for such people my class is valid, or my class is conducted. People who come once in a while simply come here, see for 2-3 minutes and tell, okay, everything understood. Nothing understood, zero. Okay, now, see, limitation, contraction, that is delta, is limited to 0.17 millimeter. Means delta is not to be more than 0.17. After this question, I will tell about that not more than, not less than, etc. etc. When you have take higher value, when you have take lesser value, that all I will tell, minimum, maximum. I will discuss something which is useful not only for this subject, for your entire education. Okay, start. We have, now write the equation for delta. Delta equal to PL by A. Delta equal to 0.17 substitute. P, 80 10 to the power 3, length 750. A is A only by E. You get required cross-sectional area 1764.706 mm square. You get the area. Okay. Once you get the area, then see what they want. See, they can give you D1 and ask you T, or they can give D1, ask you D2, or they can give D2 and then ask you to find T, or D2 and ask you to find D1. These all I will explain in the little later stages. Okay, now we got area required is 1764.706 mm square. See, this area equal to how much? See, area of a circle is pi d square by 4. Area of a hollow circular section is pi by 4 of outer square full area minus pi by 4 of this square, or you can tell equal to pi by 4 of d1 square minus d2 square. This is the formula for area for circular section, hollow circular section, pi by 4 of outer diameter square minus inner diameter square. Now you substitute, d1 is already known, substitute and get the value of d2, then get thickness. I will explain now. See, now I can remove these things all not required. I will remove unwanted part, so that space problem is there here. Okay, no problem. Everything I can remove. Okay, now substitute. Therefore, 1764.706 equal to pi by 4 of d1 is 100 square minus d2 square. You can write here substituting d1 equal to 100 millimeter. How means given in the question. Given. Again I am writing. Therefore, you get the value of d2 in millimeter. How to get it? I should not explain. See, you multiply this one, take other side. See, I will tell you how to calculate now. Directly 1764.706 into 4 divided by pi will give you this number. Now, this I will shift that side. d2 square I will bring this side. So, I will get this number will go that side into minus 1 plus 100 square. Then I will get d2 square, take root, answer equal to 88.05 millimeter is d2. Yes, we got the value of d2. Or first of all, high school students will solve this one. Okay, now we want not d2, we want thickness. Now to get thickness T, see correctly the sketch there. I wrote a sketch there, refer that sketch. Or if you got difficulty, you can see it, because by this time you should have written that sketch, or see the next part of explanation. We have your d1 equal to d2 plus 2 times t. Wait for 1 minute. As soon as this is over, I will explain that one. Or common sense only. See, y outer diameter d1, a little bit upper side because camera problem. Outer diameter d1 equal to inner diameter d2 plus thickness. Therefore, substituting d1 is 100 millimeter, d2 is 88.05 plus 2 times we need thickness t. Therefore, you get thickness required t. It will come in millimeter. That's all. You don't provide. You tell what is the thickness required. They are not asked you to provide thickness. That is called, if they are suggest, I will tell it later. Okay. 100 minus 88.05 divided by 2 is 5.975 millimeter. It is 5.975. Okay. Required T equal to 5.975 millimeter. That's all. Stop there. Suppose they asked, propose or provide suitable thickness. Then you can round off to little higher side, because thickness, if you give more, it becomes stronger. You can tell 5 second first decimal, 5.975. This 7 will make it 0 here, this will become 6. Say, you can tell later, say 6 mm. But here, stop. Okay, we got area. Now, what they want further? See, now they want what will then be the stress in the member. See, area is known there. Okay, start. Once you get that one, see, to find stress, sigma equal to P by A. Start. P equal to, what is P? 80 10 to the power 3 divided by area is 1764.706. You get the stress in Newton per mm square. What nature? Compressive nature. 80 10 to the power 3 into 4 divided by pi divided by, oh sorry, already area is there. See, I am finding area using D1, D2. Pi will not come because already area is there. Divided by 1764.706. 45.333. 45.333 Newton per mm square. I always take the class like this only. Not by showing very angry face like that. But I show angry only, I will show angriness only when people tell we did not understand because we have not studied, or I came directly to this class, previous not studied. Then I, not angry actually, little adamant I will be. I will go and study first, then come. If you want to learn from me, you should follow whatever I tell. It is a condition. Okay, now over. Now, just to understand, see, you can find the stress directly without using that area. I will tell you, not required for you. See, delta is limited to 0.17. I will divide by 750, delta by L. I will get the strain. The strain I will multiply by Young's modulus. See, 45.333. But not required for you, leave it. Okay, now, question 4 over. Next I forget question number. I will write somewhere here, question 5. Sometimes I forget the question number. Okay, now, before going to the next question, I will make one important concept clear. One very important concept. This all I will remove now, not required. Only in the beginning I write class number and course. Later, not required. See, make a note. Rectangular section, area equal to width into thickness or breadth into depth, people know it. Circular section, area equal to pi d square by 4, everybody knows it. Radius we don't use. Now, consider hollow circular section. See, remember one important note you have to write. Very powerful note. You should write what all he is telling now. It is required not only here, 10 times more required when you go to torsion. There, because your entire syllabus is torsion for circular shaft, usually hollow shaft only. So, some principles I am telling, as it is, you should remember when you go to hollow shaft. There, some ratio will come. That I will explain at that time. But what I am telling today, I will not explain. I will tell earlier told, go back and go through the class or see your notes. You should have prepared it. So make a note required for torsion later and also for columns. Okay. let D1, my symbol is D1. D1 be outer diameter. Dia, sufficient. Dia means diameter. Okay. Dia. Some people call this as external diameter. Both are same. External dia. Okay. And let D2 be inner diameter. Don't write dia, write diameter. Some people call internal diameter. Internal diameter. Okay. Let T be thickness. Thickness. See, I'll write here. Okay. Now see, this is outer diameter D1. This is inner diameter D2. This is your thickness T. Now, sometimes what people do is, no problem, it is not wrong. They write, okay, no problem. Outer diameter is capital D, inner small d. Okay, this also I will use somewhere later. But usually, I prefer D1 outer, D2 inner. Or sometimes, some people write DE external, DI internal. Or DO outer, DI internal. Internal or inner. Okay. Now, my symbol is D1, D2. Then, cross-sectional area A. See, this area, this is empty portion equal to pi by 4 of D1 square minus pi by 4 of D2 square. Or directly you can tell area equal to pi by 4 outside times next time D1 square minus D2 square. This everybody knows it. Now the most important, I want to connect D1, D2 and T. Why you don't bother? There's a reason. See, one of them I already used it just now. See, one by one. Suppose you want expression for D1. See, D1 equal to, see here, D1 equal to whatever is D2 plus T plus T. So, D2 plus 2T. This will give you D1 if you know D2 and T. Then, or, see here, suppose you want D2. Answer, see, D2. D1 is the outer diameter. From D1, subtract T. See, last time to get D1 to D2, add T, add T. Now to get D2 from D1, subtract T and subtract T minus 2T. Or lastly, and also, suppose you know D1 and D2. You want T. What you do? Directly T equal to, see here, D1 minus D2. D1 minus D2 will give you 2 times thickness. So, divide by 2. If you observe, all these three are same. See here, D2 equal D1 minus 2T or T equal to D1 minus D2 by 2. But that is formula. You remember this way. If you know D2T, D2 and T, how D1 you can find. Or if you know D1 and T, how D2 you can find. Or if you know D1 and D2, how you can find T. So this is very important. This I will not explain again and again later. I will explain earlier. Okay. Now I will go to next question. Question number 6. I will make a note here. Question 6. Question number 6. 6 correct? Just confusion. 6 So see, question 1 in the class over, question 2 over, question 3 over, question 5 I think, not 6. I told next is 5. Now question number 5. See, again confusion. If there's a confusion is there, question number, you correct it. Don't make issue of it. First class I solved one question, one homework I given second one. Second class I solved one question, 2. Then just now one question solved, 3. Yes, fourth question. 3, not fourth. First class one homework, 2. Second class 3. Just now one question over, 4. 5, correct. Okay. See. Now this question, be careful. A member of rectangular section, all are important from exam point of view. Rectangular section is required to resist an axial tension. This time they are telling tension of anything, 60 kilonewton. Okay, force given. Now further, E equal to, question paper given, 125 GPa, means it is not steel. Why should you bother? Some material. Usually for steel, if not given, you can take E 200 GPa or 200 10 to the power 3 MPa. That way it later I will give different E values for you to remember. But usually they will give other E values. Only for steel they will tell, you can assume it. If required only, E not epsilon, E is, see this is E, Young's modulus, 125 GPa. Now, find cross-sectional dimensions, or I'll put full, see, cross-sectional dimensions if, see now, strain, not stress, strain is limited to some number 0.2 10 to the power minus 3. Now, this is the condition here. See, this question you cannot solve because rectangular section has unknown width and depth. So they should give a link. See, hollow circular section D1, D2. D1 they are given. Only circular means diameter you can find. So take in the question, take width equal to width as twice the thickness. They have to give this one. Twice the thickness. Over question. Okay, start. First, put a member. Just like that. Show the member here. Axial tension. How much? 60 kilonewton. See, length is L. They are not given L deliberately. And if I take cross section here, you can see a rectangle section. Say this way, width is B, thickness is T I will take. Let B be the width, B be width, and T be thickness. And in the question given, what? B equal to 2 times of T. See here, take width as twice the thickness. This is very important. Okay. Now, remember important statement. Start. Now, remember data as usual. Now I am not writing story all. You should write all in newtons and millimeter. See now, I will start waves. Axial force P. You should write not waves. How much? 60. Not waves actually. I have written question number 1, question number 2, question number 3, question number 4 I written. Now I am not writing. 60 kilonewton, convert to Newton, 60, 10 to the power 3 Newton. Then length is not given. Cross sections are not given. Modulus of velocity E equal to 125 GPa or equal to 125 10 to the power 3 MPa. This is given, that is Newton per mm square. Next time this also I am not writing over. Now, right, limitation. This is the most important limitation. Strain, that is epsilon. Be careful, I told repeatedly, epsilon, that is strain is epsilon, is not to exceed, what they told? Is not no, they use same language. Is limited to. Both are same meaning. This I will tell little later in the class, that limited to, not to exceed, permissible, all I will tell. Limited to 0.2 10 to the power minus 3 is the condition. So that is, you can tell delta, not delta, see, habit, epsilon not to be more than 0.2 10 to the power minus 3 is the condition. Okay. Now, see, last time one question, delta condition given. This time delta is not given, epsilon given. No problem. See, we have strain epsilon, directly right here, epsilon, not E, epsilon equal to delta by L. You should write delta is the change in length. Here it is increase in length. L is original length. Original length. And also we know that delta equal to PL by A. Therefore, see now, your strain epsilon will become delta by L equal to PL by AE divided by L. L will get cancelled, or you get epsilon equal to PL by PL. L will not come. P by AE. P by AE. A into E. See, I am telling E here. E. No, or 1 minute. See, P by A is the stress. Stress by Young's modulus is strain. You know it. Okay, now do one thing. Substitute epsilon equal to, how much? Epsilon equal to, what they given? 0.2 10 to the power minus 3. And area equal to, see, B into T. Area is rectangle, B into T, or further equal to 2T into T equal to 2T square. In the bracket, substituting width equal to 2 times thickness as given in the question. Therefore, your 0.2 10 to the power minus 3 equal to, where is the load? 60. Okay. 60 10 to the power 3 divided by B into, not B into T, it is 2T square is the area. How 2T square? Breadth into thickness. Breadth is twice of T. So twice of T into T. High school mathematics into 125 10 to the power 3. Therefore, you get the value of T in millimeter. Right answer. You get T in millimeter. 0.2 minus 3 is the value of this one. Then into 2 into 125 10 to the power 3 divided by 60 10 to the power 3. That will give reciprocal of T. I should take reciprocal. Y means you solve as usual. Then take root. 34.641 millimeter. 34.64 sufficient. Why? Because it is millimeter fraction of T. Then they want a cross-sectional dimension. Your B equal to, as per our condition, 2 times T equal to 2 times of 34.64. Therefore, B equal to 69.28 millimeter. 28 millimeter. Okay. Over. Question over. They can do one thing, they can round off to 70 mm to 35 mm. That is their choice. Requirement is this much. question over. Okay, now I will go for the very powerful aspect, that is the stress limitation and the maximum limit and minimum requirement. All those things I will explain here. But I think before that, better to do one more very important question. That is the question of double limitation. Yes, sometimes in exam they give question of double limitation. Once I solve that question of double limitation, then if I explain the requirement, minimum, maximum, limitations all, it will be crystal clear for you. So better I will go to question number 6. Remember, very, very important question. Okay, I will write and start. We will start question number 6. Question 6 is very, very important for understanding the concept. I will let you know that later why it is that way. Don't think he is telling every time that later. Later time comes. I always tell some principles when the requirement comes, not earlier. Earlier you forget. If it is told at the time when it is required, it has more effect. See, a steel cable, remember they told cable. When it is a cable, when you support a load, it can take only tension. I told it earlier. It cannot take compression. So understood, it is tension only. Moreover, see, they told here elongation. Even instead of elongation, if they told by chance change in length, even then you should note that because it is cable, flexible member, it can take only tension. See, a steel cable is of length 5 meter. So there is a cable of length 5 meter. Imagine somewhere fixed there, freely hanging. Length is 5 meter. It is required to support a load of 24 kilonewton. Say written here. So length is 5 meter. Once, see, if it is down 24, up 24, axial force will be 24 kN tension. This you already know it. Okay. Then further, find the least diameter required. The term least is very, very important. This is where maximum people will make mistake. So find the least diameter required. In the question paper, they won't highlight that way. They will write like a usual statement only. So find the least diameter required if condition stress is not to exceed 750 Newton per mm square. This is a high strength cable. It can easily take 750 Newton per mm square. Okay. Now further. And means not one condition, there are two conditions. And elongation is limited to 18 millimeter. So what they want now, you have to find the diameter for the cable so that at any cost, stress should not exceed 750 Newton per mm square. Remember, stress is bad. Something bad is to be controlled. Something good is to be allowed. Then elongation also is bad. Too much elongation means deformation more. Elongation is limited to 18 millimeter. See, they are told the length here. Therefore, when you put delta equal to PL by AE later, you know length. Previous class I solved a question where instead of elongation, they limited to strain. No problem. Then, see, delta equal to PL by AE, divide by L, delta by L becomes strain. So, you make a note. Then the length is not required. See, giving limitation of delta or giving limitation of strain, both are same. I already told last time, every problem solved, you should make fair copy. Now see, after question 6, I will do question 7. That is the last question of the series. There also there will be double limitation. There, question is to find something else, not diameter. There, instead of elongation limitation, I will give strain limitation. You can make out there what is the change. No change. Okay. Now, therefore, see the cable is like this now. Load is 24 kilonewton. It has to support. So cable will be in tension by 24 kN. So P equal to 24 kN. Actually not required. Understood. Till I will write no space here, tensile. Okay, space is not there. Now, what you have to do? The cable should be able to take resist a tension of 24 kilonewton. Now, you have to provide suitable diameter or find the diameter so that two conditions are satisfied. One, stress is not to exceed 750. Two, elongation limited to 18. See, not to exceed or limited to or maximum permissible, all are same. After this problem is over, I will go for some discussion about some common sense part where I will tell the different meaning of this one. Okay, now take E equal to 210 Kn per mm square. They told 210 Kn per mm square. Okay, sorry, here see, here GPA will not come because they told Kn, therefore I thought GPA given. Okay, no problem. Okay, start. Now, one note you write here, see, they told find the least diameter required. You write here, instead of asking you find the least diameter required, they can use another English word. They can ask you find minimum diameter required or minimum required diameter. You make a note. Asking for least diameter required is nothing but asking for minimum diameter required. Make a note. Over. Now, let D be the diameter, required diameter in millimeter. So, if I cut the cross section, you can see a circular section, cable is circle of diameter D in millimeter. Over. Now, I told up to question number 5, I wrote statement solve. Now onwards, I won't waste time. You should write. See, when I put waves means, you should not write waves in examination. People get angry. You should write the meaning. See, axial force P over tension, original length L, 5 meter or 5000 millimeter. I told we are going for newtons and millimeter. One note I written somewhere, I think. Not written. Okay, I write here. We will solve everything in note, newtons and millimeter. Make a note. Then, Young's modulus of elasticity E is 210 Kn per mm square. This time gigapascal, megapascal not given. They told 210 Kn per mm square. Convert kilonewton to Newton by multiplying by 10 to the power 3. And since diameter is D, cross-sectional area A is pi by 4 of D square. This is a basic data. Now, once again I written correctly. See, these are all given in the question. This you are right in the answer booklet. See, limitations means conditions. You know what is limitation? Someone will tell you, do not do it. It is a limitation. Okay. Limitations. 1. Stress, that is sigma, is not to exceed 750 Newton per mm square. That is limitation number 1. Second limitation, elongation, that is delta, is limited to 18 millimeter. So now your condition is what? 1. Stress is not to exceed 750 and elongation is not to exceed 18. To satisfy both the conditions, you have to find the diameter. See, now one note dictated in the class, write it. I will tell you. Whenever there is only one unknown, see, unknown is D, but multiple limitation, maximum for you is 2. Write that much sufficient. You won't get 3, 4 like that. You write that way. For only one unknown, if 2 conditions are there, then you should write what all I am telling, you have to write. Then what you have to do is find the unknown considering each limitations separately. Find the unknown considering each limitation separately. Means once find D based on stress limitation. Get the answer. See, answer is there. Again find D based on second limitation, that is elongation limitation. Answer is somewhere here. So, and whatever answer you got here, do not use here. Result we got in the first limitation answer should not be used for second limitation. That answer Data will remain same because we are asked to find diameter D once considering stress limitation, once considering elongation limitation. So start. Write it. So write there. Whenever only one unknown is there, but if you have got two limitations or two conditions, find the unknown considering each condition separately and do not use the result of the first condition for second condition. Find the unknown only once based on first condition, once based on second condition. Once you get the two values, then select applicable value. Remember, right here. Lastly, select applicable value using, usually I will tell in the class, using common sense. Or common sense means what? You should think and decide. But I will make it clear. How, see, two answers came here. Which one to select finally, I will tell you. Okay, start. Calculation of D based on stress limitation, that is, stress is not to exceed 750 Newton per mm square. Governing equation, stress equal to P by A. Substitute stress equal to 750, P is 24 10 to the power 3, area pi by 4 D square. You get required diameter D in millimeter. This is the diameter required to control the stress. Okay, now, later I will tell. Once again, some more principles are there. Calculation of once again D based on limitation of elongation. Now they want what is the diameter required to control the elongation to 18 mm. Make a note. Instead of elongation, they can give strain limitation. Then delta by L will give strain. L is not required. This I told in the last class. Start. Governing equation. Delta equal to PL by AE. Substitute delta equal to 18 millimeter. Substitute. Sometime in the class I will tell. See, 24 10 to the power 3, 5000 by pi by 4 of diameter square. What is the diameter? I will show the answer here. Student will tell, sir, 6.383. Okay. In the class I will write 6.383 square into 210, 10 to the power 3. Then I will ask them, what you are doing now? Sir, there is nothing to find. Yes, full examination. You have to keep on looking there only. If you use this diameter here, full exam, you have to keep on looking at what to do. That's why I told, find the unknown D based on each limitation separately. So you got D. Now answer is 6.358 millimeter. I set the question so that both are very, very nearby. See, that I can set. Minute difference is there. Okay, now over. Last statement now. See, now required to control the stress, required diameter is 6.383. To control the elongation, required diameter is how much? 6.358 millimeter. Now the time has come to decide the answer. So question is not required. I will remove this one. Remember, they want the least diameter required. They can also ask you, instead of least diameter required, they can ask minimum required diameter. Both are same meaning. After this problem is over, I am giving an example. There I will tell. Okay. I will write here now. Therefore, now see, what you have to do is, after this step is over, you write a note here. Yes, both limitations are applied. I will put dot here. Now, last part, continue here. Therefore, considering both limitations, see, both limitations, what they want in the question? Least diameter required for the cable equal to, you have to write the answer. See, this is recorded class, therefore I cannot question you. If it is a live class or offline class, I will ask the students, 6.383, 6.358. They want the least answer. Which one? 99.99% people will tell, sir, 6.35, 6.38, sir, 6.358 millimeter. I will ask them, everybody clear? Yes, sir, fully clear. Okay, good. I will tell, very good. This is actually called highest level of common sense or good knowledge or concept understanding. Very good. Keep it up, I will tell. Then I will write here 6.383 millimeter. Then some student will tell, sir, no sir, least 6.358. Sir, we told 6.358. You also agreed with us, but now you are writing 6.383. I will tell, I agreed with you just to make you happy once or to show you what mistake you are making. Just because you told, I am not going to write it. I am going to write the correct answer. It is 6.383. Then slowly, maybe in a class of around 40-50 students, one or two will slowly tell, sir, got it. One or two will tell, sir, got it. Others will be still puzzled. Here, usually I use this one to test the cleverness or imagination or concept or knowledge. But here, because recorded, I can't do anything. So I have to explain. See, so many things where I convince the students or make a deliberate mistake. Why? To correct the students. I will sometimes make deliberate mistake. Then I will correct it. My students know it. Purpose is what? Deliberate mistake means what mistake students are making, I will make the mistake. Then I will tell them, see, it is wrong. It is not that way. Some rare cases, one or two students will tell, sir, I will tell them, leave. I will tell them, I know, they know the answer. I told, leave it, I also know it. I am not that much weak. Okay. See, remember, they want least diameter required 6.380, or you can also tell other language minimum required diameter. Both are same meaning. Minimum required diameter is, once again remember, minimum means 6.383, 6.358 among the two, whichever is higher, not lesser. People will tell, sir, least, minimum. That's why higher. How much? 6.383 millimeter. This is in the examination. If they ask this way, you write this way. Okay, now, first I will explain why higher value to be taken. Okay. Technically, I will explain. If it is clear, well and good. Then I will rub everything and go for the logical part of this limitation or conditional questions, which is useful for you throughout your education. Not only this subject, any subject, especially if you are civil or mechanical, you get so many times such conditions. Then you should realize, oh, long back in strength of materials class, he told something really useful for us. Okay, I am not telling you remember me, but you have to. You should tell, yes, eye opener. In Kannada, kan teradu nodu, if you want. I usually don't use Kannada words here. So there is a hidden concept is there. 1 minute, see here. Stress correctly those who want technical knowledge, right? Others keep quiet. Suppose you feel, no, these are difficult for me. My level is not that much. I want to pass in examination. Then listen to the second half explanation. Question is already over. You can write here. Solution over. Now everything is explanation. See. And remember, this explanation, if it repeats in strength of materials, now onwards, I will not tell once again. See. They told stress is not to be more than 750. You should know stress is bad. Stress should be controlled. See, when you substitute stress equal to 750 here, we got diameter equal to 6.383. That means if you provide a diameter of 6.383, stress will be exactly equal to 750. Okay, done. They told stress is not to exceed 750. 750 is okay. Now, by chance, if you take a diameter more than 6.383, what will happen? Common sense. Diameter is good. Why? More strength. If you substitute diameter here more than 6.383, then this denominator will increase, stress will decrease. Stress will be less than 750. Good, no problem. That is what they want. They want stress not more than 750. For exact 750, this is the answer. Suppose you for some reason you substitute diameter, consider diameter less than 6.383. If you consider diameter less than 6.383, this value will decrease, stress will increase. Not allowed. Or common sense. When the required diameter is 6.383, to control the stress, you should provide either that diameter or more. Why? Stronger. Okay, now you write a note here if you want. Now, at any cost, you should not provide a diameter less than this value. If you give more, no problem. You give 10 mm, no problem. Very strong. You can't give 6 mm. Now, come down. Here, delta limited to 18. When the D is 6.358, delta is exactly equal to 18. Yes, limit. Suppose you provide D more than 18 mm, more than 6.358 mm. Wire becomes stronger, cable becomes stronger. See, the denominator will increase, means delta will decrease. Good. But if you consider a diameter less than 6.358 millimeter, then delta will increase, which is not allowed. So, to control the stress, you need at least 6.383. To control the deformation or delta, you need at least 6.358. So, among the two values, whichever is higher, you make a note here, whichever is higher, even though they told least requirement. I will, after this question is over, I will give you practical example. There, see, suppose you take 6.358, if you substitute here, stress will become more. This is a real concept. Remember, this is for what? When the requirement comes. Next question I am doing is maximum permissible diameter. Maximum permissible load, not diameter, by slip. Load. At that time, see, maximum permissible they are asking. You should take the lesser value, not higher value. Oh, I will do one thing now. Better, I will solve that question also now. Then for both of them, I will give combined basic theory or common sense. What? Common sense concept I will give for both of them. So, I will start question number 7 now. That is where once again there will be double limitation and they want to find what load it can support. I will explain that one. I will finish that. Then go to that logical discussions. Then go to one more question today that is regarding some tension test done in the lab, result sheet. That I don't have any result sheet here. I will imagine some value. Somebody can comment. That value is not, maybe not as per exam date, what do you call it? Experimental data. I will tell them, imagine given in question paper. That's all. There are so many questions I solved in the class, given in question paper, where so many blunders are there. So, once given in question paper, students what? You solve as given in the question paper. Okay. First time, go to question number 7 now, complete it, and for both the questions, I will give common concept for you, that logic. Now, next question, question number 7. It is identical to last time question. See, question 6 and question 7 both are double condition. And it covers more important concepts. See, a vertical member. So, member is vertical. of hollow circular section has external diameter of 90 mm and thickness of 8 mm. So member is like this, length is not required here. I will tell you later why. See, if you take the cross section, you can take a circular section of outer diameter 90 and thickness 8. So remember, for area calculation, we want inner diameter. So what you can do? Outer diameter 90, thickness 8. So little later, internal diameter D2 equal to D1 minus 2 times thickness. It came 74. So your area will be pi by 4 of D1 square minus D2 square will come pi by 4 of 90 square minus 74 square. Okay. Now, see, in the earlier question, I told outer dia, inner dia. I change the language now. I called what? External diameter, internal diameter. Both are same. Okay, now, what they want? They want to find the maximum permissible value of P. What is P? First they are telling it is subjected to axial compression force P. Somebody wants to apply a force P, compression. Now they are asking you, what is the maximum P you can apply? See, last time least or minimum required. Now reverse. Last time why minimum required? It was diameter. Minimum required because you can provide more. Less you can't give. Now why maximum? Because dangerous. Applying more and more load is dangerous. So see, like in the road, going more and more speed is dangerous. So what they tell? Maximum speed permitted. That both of them I will explain after this question is over. I told earlier. Okay, now axial force is P, compression, everything newtons and millimeter. Cross section area already told. Modulus of elasticity they told. How much? Where is it? 150 GPa. That is not steel, some other metal. Why should you bother? They told E, accept it. Over. Now, see, this time once again I wrote. Next time I will not write this statements all. Those who are serious should write. Otherwise, pay penalty later. Now, start. Limitations or conditions. Two conditions are there. See, limitations, plural, means two are there. One of them, stress is not to exceed 200 MPa. This already I told earlier. Second one, strain epsilon not to exceed 1.2 10 to the power minus 3. Here length is not required. Remember, if they give the length instead of strain, they can give delta limitation. That is last time question. Both are same. Earlier also told for you. Okay, start. Note, dictated in the class. I am dictating now. Write it. Once again I am telling, whenever there are two limitations, but only one unknown is there. Here unknown is only P. See, unknown is only P. But you have to find the value of P, the maximum limit for P, satisfying two requirement. So whenever, already told last time, previous question, once again I am repeating. Whenever there are two limitations are there, but only one unknown is there, find the value of unknown considering each limitation separately. Do not consider the first value for second calculation, and then finally you consider both the limitations and conclude the question or final judgment, or lastly decide what is the applicable value of P, once again using common sense. Okay, start. Calculation. See, calculation means calculation, short form. Slowly you will get used to it, my short form. See, solution. SL, here I wrote full. Sometime I write SOLN, solution. That you can make out. Calculation of P based on stress limitation, sigma limitation, sigma not to be more than 200, sigma equal to P by A, substitute sigma 200 MPa, MPa means Newton per mm square, substitute, your P will come, see, stress in Newton per mm square, area in mm square, P will come in Newton, 412.1 177 10 to the power 3 Newton. That later you can tell 412.177 kilonewton, not now, later. Okay, now I can remove this side. This is not required. So I'll remove this one now. I want some space. Now after that one, see, even this also I can remove. I can have more space. Okay. Now once you finish this one, see, come here. Start. Same statement. See, I will put calculation of once again P. You got based on stress condition, you can apply that much force. Calculation of P, see there, based on what limitation I told? Strain limitation. Based on strain limitation. That is nothing but delta limitation only. Strain limitation. That is epsilon limitation. Epsilon. That is, condition is what? Your strain epsilon should not exceed, where is the value? 1.2 10 to the power minus 3. Luckily not removed. Then gone case. If I remove this one, how I can remember it? Over. No unit for strain. See. Now, we have delta equal to PL by AE. Now do one thing. Suppose they give delta limitation here, then they will give the length for you. Substitute here only. But here, strain given. Also we know that strain epsilon equal to delta by L. This I told in the previous classes. Therefore, your epsilon will become delta by L, that is PL by AE divided by L, or you can tell your epsilon equal to P by AE. That's all. L will not come. Okay. Now, what you do? Substitute strain epsilon equal to whatever they told. Where is it? 1.2 10 to the power minus 3. What happens now? 1.2 10 to the power minus 3 equal to once again P. Do not use that P value here. You have to once again find the value of P for the condition divided by area is, I removed the area. Fortunately, I can see the area there. 2060.885 into E is 150 10 to the power 3. Therefore, once again you get the value of P. You can make a note here. Some note you can write. This is the value of max. This is the value of P, which will produce a stress of 200 MPa or 200 Newton per mm square. Whereas this is the value of P, which will produce a strain of 1.2 10 to the power minus 3. 1.2 10 to the power minus 3 into 2060.885 into 150 10 to the power 3 divided by 10 to the power 3. 370.959. 370.959. Third decimal sufficient. 370.959 10 to the power 3 Newton. Okay. Now think. If you apply a force of 412.177 kilonewton for that cross-section area, stress will come 200. Suppose you apply a force more than 412, stress will come more than how much? 200. So at any cost, if you want to satisfy the stress condition, you should not apply a force more than this one. Last time I told, you should not give a diameter less than that value. Now reverse. You should not apply a force more than this much. Okay, conclusion. Next. If we apply a force of 370.959 here, strain will come 1.2 10 to the power minus 3. Suppose you apply more force, strain will become more, not allowed. So to satisfy this condition, you should not apply a force more than 370.9. That is telling should not apply more than 412. This is telling should not apply more than 370. Therefore, among the two, applicable value is 370.959. See, they told maximum. Some student will make the mistake. The moment they see maximum, they will write this answer. No. Because maximum limit, I told, as soon as this example is over, that logical part I will explain to you, useful for your lifelong education. Okay. Now, conclusion I will put here now. Okay, I will put here only. Last step, this is not required. See, now I write here conclusion. Exam don't write conclusion all. They will tell don't conclude. You don't have to write conclusion. I am ending like that. Write the answer. Therefore, see, considering both limitations, you want to satisfy both the conditions. Just 1 minute, I will give example. Both limitation, maximum permissible, their language, see, per sufficient, permissible value of P, they only told P. Suppose in the question paper, sometimes they give W, call W. Suppose they don't give symbol, you write, let P be the force. Okay. P is how much? Among the two, whichever is least, 370.959 10 to the power 3 Newton. That is, you can tell 370.959 kilonewton is the answer. Write whichever is least. Exam you don't have to write. Whichever is least. Maximum limit means whichever is least. This question over. Now I will give you the logic of this minimum and maximum. I told you very useful for further education. Okay. I have to remove, throw the papers over here. Okay. Full I will remove. Some 10 minutes I will discuss about this minimum maximum. Remember once for all, and remember those who are in civil, when you go to RCC and steel, this concept is very, very important. Sometimes you get minimum reinforcement, then minimum number of bars, sometimes you get maximum spacing permitted, so many things will come, maximum permissible deflection, so many terms will come, L by D ratio, etc. Even for mechanical also, there will be some terms connected like this. Now, see, what I am going to tell is pure practical knowledge. First, I will tell you regarding the minimum requirement. When first of all, remember, minimum requirement means what? You should write what all I am telling now. If you are serious, write everything. Somebody may laugh. What in the structures class all, you write this money matter. You tell him, you keep quiet, don't interfere. It is between me and him. Him is me. He told something useful for me, I wrote. You never comment. You never comment like that. If you got enough courage, go and comment with him only. I know how to take care of such people. See, I am going to lower level only to make you understand. I can go to very high level. If I go to very high level, what happens? Student will tell, sir, no sir, we don't want sir. They know. We can make out, or we know what level you can talk. I will tell pure technical, I can take class. Next class, nobody will come. I will not do that way. See, now, start. First, you remember one thing. Write everything. Minimum requirement means you should not take less than that value. You should take either equal to that value or more. Just for example, I give same example every time because why? Best example. Examination minimum for pass is 35. Sorry, nowadays it is 40 I think. Okay. When I was studying it was 35. Okay, imagine 40. Some subject out of 140. I am very strict. I am a person who insists that they should make it at least 50. Okay. At least 50% knowledge required. Okay. Minimum 40 means you should get in the class I will ask. See, for passing in examination, minimum is 40 means you should get either 40 or less than 40. Correct? Student will tell, no sir. Why? They know it. No sir. You should get more. Why? Minimum. Sir, minimum, sir, that's why higher. There they understand. Here they don't understand. When it comes to structural language, they don't understand. Okay. Or, suppose you want to go somewhere. Your expected expense is 1000 rupees, Indian currency. Means minimum money you have to take is either 1000 or they will tell, sir, more than 1000. Why? Sir, because expected expense is 1000 means you should not take less than 1000. Better take either 1000 or more than 1000. Or remember, getting more marks in exam, taking more money is safer side, therefore higher side. Maximum limit, speed limit is the best example. On the any road, maybe highway, or imagine some highway type road, it is written maximum speed limit is 80 kilometers per hour. Means what? I will tell the students, maximum speed limit is 80 means you should drive at a speed of either 80 or more than 80. All will shout, no sir. No sir, they know that I am joking. Sir, you should drive either 80 or less than 80, sir. Why? That is the maximum speed, sir. Oh, there they understand. Here when they come maximum, they make mistake. Why? That is practical. This is structures or mathematical. That is the problem. Now, this is the case. So, whenever there is a minimum requirement is there, you should take higher side. Whenever there is a maximum limit is there, you should take lesser side. Why reason? Minimum means should not take less than that value. Should not take less than that value. Either take that value or more. So minimum requirement will come when something is good. Maximum limit means should not go above that value. You should take either that value or lesser. Why? Maximum limit will come when something is bad. See, last time diameter, good. Why? Stronger, minimum requirement. This time application of load, bad. Therefore, maximum limit. This is when there is just one condition. In structural design, RCC, steel, prestressed concrete, bridges, etc. for civil and for mechanical also, in so many subjects, there will be multiple limitations, multiple minimum and multiple maximum. What to do? See, just for example, once again, I will tell minimum requirement. I will go for money matter, easiest to understand. Money matter, I will talk in Indian currency, that is rupees. See, just to understand, imagine you have to go to examination. Your house is somewhere out, much away from the college, maybe around 10 kilometers from the college. You don't have a two-wheeler. You have one option, go by bus. Second option, either you can go by bus or you can go by auto. Anything will do. Now, examination, you have to reach in time. Someone, you know that bus timing is so and so. You know that bus will come at a particular time. Maybe at 7:30 a.m. bus will come. You leave the house at around 7:15 and go to bus stop. From there, if you take a bus, it may reach examination center maybe at around say 8:30. Examination is at 9 a.m. So you will reach well in time. Or this is danger. Nowadays they tell reach before half an hour. Or imagine exam time is 9:30. Okay, 9:30. You reach 8:30 comfortable. See now, to go by bus, imagine you require 50 rupees. You need 50 rupees. So, based on the bus journey, based on the requirement of the bus ticket, you have to have 50 rupees with you. Coming back, some will tell, sir, coming back, no coming back. Coming back, somebody is dropping you. Then students will tell, sir, food, no food. Somebody will give you. I got answer for everything. Sometimes student will tell, sir, whatever coming back, I will come and drop you. Oh, okay, sir. Food, I will give you food for you. Exam center, you come. Okay, sir, go on. To go by bus, you require 50 rupees. But remember, there is a problem. That bus sometimes may not come. It happened earlier. Suddenly one day that, or you reach what? You reach around 7:30 to bus stop. See, 7:20 you leave the house and bus will come by 7:30. That bus has reputation. Sometimes it comes little earlier and goes. Next bus will be after 8 o'clock. You can't reach examination hall. And some rare cases, what happened is the bus gets cancelled. That bus may not come. So there is no guarantee that that bus will come. Then you have to go by auto. No other way. If you go by auto, imagine you require around, if that is 50 rupees, as per Bangalore condition, you may require 200 rupees. Okay. To go by auto. Around. That is where bus ticket is total come. 2 stages may be there, 50 rupees. I am thinking to require 200 or little more. Okay, leave it. 300 rupees to make clear. Why? 50 rupees bus journey, say 300 rupees. Now, in case you don't get the bus, you have to go by auto, for which you require 300 rupees. So, based on the bus ticket, you have to take at least 50 rupees. Minimum 50 rupees. At least means minimum. See, parents will tell, at least pass. At least get 40, they will tell sometime. Our prestige question, at least pass. So based on the bus journey, you need minimum 50 rupees with you or at least 50 rupees. Whereas in case some problem comes, you have to go by auto, you require at least 300 rupees. Now, answer the question I will ask the students. Now, considering both limitations, you have to go to examination in time. Bus is not guaranteed. If you get the bus, well and good, you save the money. But there is no 100% guarantee that bus will come in time. Therefore, I will ask the students, to go safely to examination hall, for bus ticket you need minimum 20 rupees, 50 rupees. For auto fare, you need minimum 300 rupees. How much minimum money or at least how much money you should take from the house? Within no time, all will shout, sir, 300 rupees. Then that diameter what you told earlier, when I told one condition require diameter of 8 mm, suppose, I don't remember, other condition needs 10 mm. What is the minimum requirement? All of you told 8 mm. Remember? Sir, that time you are not knowing. Oh, now, sir, now knowing. I will tell them, now you are knowing practical matter because it is money matter. If it is diameter, still you will be scratching your head only. What is this diameter, etc. See, that happens always. So, you require involvement. So, remember, 50 and 300, think a little, at least minimum you should take 300 rupees. So when multiple requirements are there, then minimum value, if they ask you how much is the minimum requirement, it is always among the multiple value, whichever is highest. Some student will got it, sir. What? Sir, minimum means maximum. Now also, sir, maximum is minimum. That is a crude method. Don't do it. Sometimes people do that way. Oh, multiple minimums are there. Maximum take it. Multiple maximum, minimum you take. Okay, correct. Okay, now, this is that way. Now, come to second example. When maximum limit comes, best example is speed. See, police department has put a board on highway that speed limit is 80 kmph. You got a vehicle with you, kmph. This is as per traffic police. As per traffic police. You are again going to examination. Suppose you get caught, then what will happen? Your vehicle will be seized. Problem will come. Or you are going emergency work. So you can't stop. Police department, traffic police told, max speed limit is 80 kmph, means maximum permissible speed. That means you should not drive at a speed more than 80. But your vehicle is not in good condition. You yesterday only imagine you took to your mechanic. Mechanic told you, see, now mechanic told your mechanic, see sir, see this vehicle, see that spring has got problem, shock absorber problem, axle is little weak, also your tire and tube that is not good condition, some problems are there. He will tell it is better if you go at a speed of max, he will tell better your speed does not exceed 60 kmph. This is the mechanic's verdict. So police department, traffic police telling you should not go at a speed of more than 80 kilometers per hour. Mechanic told, sir, your vehicle problem is there, danger, therefore for your safety and so that vehicle will not give trouble or something, axle got cut or shock absorber cut means your vehicle is gone, then it will come to standstill. He told, better not go at a speed of more than 60 kilometers per hour. Now, satisfying the traffic police condition and also satisfying the mechanic's requirement, I will ask the students, what is the maximum speed you can drive? They all will tell, sir, 60. No, maximum 60, sir. Why? Sir, if I go at 80, vehicle problem will come. But if you go 60, police problem will come. No, sir, how police problem will come? They told speed limit is 80. If you are less than 80, they are not bothered. Oh, clear? Fully clear. But when I tell P is the force, 1P you got based on stress condition, 1P you got based on strain condition, what is the maximum permissible value of P means they will tell higher value there. Why? That is strength of material, structures or mathematics. This is common sense. This will work out. So remember now, so when there are multiple maximum limits are there, both are bad. See, speed is bad. Then the maximum speed you can go or you have to select among the two values whichever is lesser. Now, sufficient, I will conclude one thing. I tell in the class also, see, when somebody is below you, minimum requirement like this, you try to lift him up. See, minimum is like that. See, when somebody feels depressed, he tells, I am useless person, I have not studied properly, my life is gone, my education gone, he feels depressed. Then you try to lift him, give inspiration. Don't tell him you are useless. See, he will tell, I am thinking of committing something bad. You tell him, no, you have got capacity, come up in the life. When someone is depressed, lift him up. And when someone talks too much, arrogantly, you want to bring him down. See, your tendency is to what? He is talking too much. It's high time I take care of him and see that what? He loses his face. So, for a minimum requirement means either equal to that value or more. Maximum limit, either equal to that value or lesser. Multiple minimum, select the highest value. Why? Because either the highest value or if you want furthermore. Multiple maximum, pick the least value, either that value or further lesser. Hope concept is fully clear. Make a note. Now see the two questions previous. One question number what? 6. It was that requirement of diameter. Like requirement of money, take higher diameter. This is previous question. Question 7 is what is the maximum permissible load? Bad. So like maximum permissible speed, take the lesser value. Okay. Now this is also over. Today's class I will just take up one more question that is question number 8 I wrote there to understand question 8. This question is a problem. I should write somewhere. Question 8, I will solve it. I will write and solve it. I made a note. Next is 9. So question 8 today I will solve. It is regarding tension test in the lab. Because what I will do is some of the data I don't have in I told I am in native place. Some values are there for steel. So what I will do is I will give random values. Imagine question paper problems. Nobody should comment. They will tell, no. Ultimate stress comes this much. No, my experiment result came that way. Examination question, whatever data they give, how to solve, very important question. That is, they will tell in tension test for a mild steel bar, etc. They will give result for you. They will ask something, maybe 10 marks question. Okay. I will write the question fully because there is nothing too much to explain. It is simple question. I will write the question, solve, and then explain and conclude this class. Next class, I am going to new part. Either tapering member or compound member. I will decide by that time. Whatever I give, you have to take it. Okay. Now I will start. Question number 8. I told this a question for lab testing. So question is a very popular question for almost all examinations. So be careful. So many times this question came. See, in very mechanical question, in tension test on a mild steel bar of diameter 12 mm. That is, a mild steel bar of diameter 12 mm is tested. That is usually in UTM. Now they told an extension of 0.133 mm is observed for a gauge length of 150 mm. Gauge length means original length. See, member can have any length, but when they fix the shackles, they will fix shackles here. Experiment is conducted only for the gauge length. So remember now, whatever they give gauge length, that is original length. Suppose they can give length of member is 250 millimeter and gauge length is 150, you should take L equal to 150, not 250. That 100 mm extra may be for fixing shackles. See, this way. So what experiment result you are seeing is for 150 mm. So I wrote here. See, given gauge length L 150 is called original length. Okay. Initial diameter is 12 mm. They told. Then also you should know little later you will be knowing. In case of tension, when length increases, diameter will decrease. It will come little later in our class. So time being, believe me, actually you can make out. Take a rubber band, stretch it. As the length increases, it will become thinner and thinner. Same way, if it is in compression, when the length decreases, cross section will bulge. This comes later when you go to lateral strain part. See, that part I am explaining here because later I cannot come to this question once again. Okay. Now, the load, they told extension means increase in length, and also they told decrease in diameter for a load of 20 kilonewton. Okay, now the load at yield point is 28.3 kilonewton. I'll tell you why they told. And the ultimate load is 46.4 kilonewton. You have to study stress and strain curve, that properties of stress versus strain curve for mild steel and some other ductile materials and brittle materials from textbooks. I'll put briefly here. See. Or see. It will be like this. For mild steel, it will be initially straight, linear. Then it will reach a limit called elastic limit. But actually, there is one limit called elastic limit, up to which if you remove the load, it will come back to original position. There is one more limit called proportionality limit, up to where stress is proportional strain. There is one more called yield point, when yielding will start. In absence of data, as per IS code also, that proportionality limit, yield point, or what I told is elastic limit, they are all very nearby. So here that is not observed, not possible, so common. So this is the yield point. Come what? You can tell proportionality limit and also elastic limit. Then it will go this way. Actually some upper yield point, lower yield point is there. that I am not discussing. Somewhere here there will be maximum stress. Peak value will come. That is also called as, see, this is called yield stress. That is called ultimate stress. And then finally it will break. Neck formation will be there. It will break. So now yield stress we call sigma y. Some people at the IS code calls it Fy. I will give both of them. Ultimate stress we will call sigma u. IS code will call Fu later. Okay. Now at failure, that is finally when the failure takes place by breaking, the elongation is 40 mm. See, 150 mm, it increased the length further by 40 mm. Given in the question paper. That's all. Somebody may comment, it need not be 40 mm. Question paper told 40 mm, solve it. No time for me to discuss all these things here. And neck diameter means when finally it breaks, neck formation is there. Initial diameter of 12 mm will reduce to 8.2 millimeter. Then it will break. What they want to find? Modulus of elasticity, Poisson. See, usually this Poisson's ratio they do not ask here because it comes later, but they can ask because when you write examination, you know everything. Poisson's ratio, yield stress, ultimate stress, percentage elongation, percentage reduction in diameter and cross-section area. Little more I will tell later. Okay, start. Now, one by one. Axial force, they told at a load of 20 kilonewton, they given data. You can write delta equal to PL by AE, that is based on stress proportional to strain only if what? The stress and strains are within proportionality limit. As per their data, proportionality limit or yield point is 28.3 kilonewton. So this 20 kilonewton load is somewhere here. It is within the limit. Therefore, you can consider stress proportional to strain. You should write it. See, this 20 kN load data given, they told this load less than the yield point because they want to apply what? Hooke's law there. That is stress proportional to strain, or you can apply delta equal to PL by AE. Now, load at yield point is 28.3. So load of 20 kilonewton is less than yield load. So P at equal 20 kilonewton is considered to be within elastic limit or proportionality limit, or you can tell elastic limit or proportionality limit. So for P is 20 kilonewton, extension delta is 0.133. We have, I don't have to explain now, delta equal to PL by AE, substitute delta, substitute P, substitute L, area equal to pi by 4 of 12 square, E, you get modulus of elasticity E. 199.44 to 10 to the power 3 Newton per mm square, that is 199.44 to GPa it is. For steel, usually you take 200. This is experiment. In the experiment, error will be there. You have to write whatever answer you got as per the experiment result. Okay, now, see, class, what I am going to do now for Poisson's ratio will be covered later. Today you believe me. You write here. See, now I am going for second part. See, I will put here now. See, first part I will do here. I will go for first part here. This is the first part. I am going for second part. They want, you write there, to get Poisson's ratio. Okay, I can remove this one now. This can be removed so that I can use this space. Now write, second part. To get Poisson's ratio. Poisson's ratio. Symbol is mu. Okay. Remember, formula I write here. You can write now only. See. Okay. Mu. That is called mu. Right. Your mu, Poisson's ratio equal to lateral strain. Its formula is lateral strain divided by linear strain. Linear strain. Or symbol lateral strain. I will put, say, see, lateral strain symbol is epsilon lateral. Linear strain symbol is epsilon linear. Okay, leave it. Leave it now. Now, Class, what I am going to tell, you will understand once I take the lateral strain part. But today we will finish it. See, decrease in diameter is 0.032 millimeter. So, linear strain equal to change in length by original length. Change in length 0.133, original length 150, you get linear strain. Lateral strain equal to change in diameter by original diameter. Change in diameter 0.032 by original diameter, how much? That is 12, you get the lateral strain. Okay. Now, do one thing, space problem is there, I will continue here. Therefore, after writing all this, you have to write here, Poisson's ratio mu equal to 0.2667 10 to the power minus 3 divided by 0.8667 10 to the power minus 3. Therefore, write Poisson's ratio equal to whatever answer. For steel, it is approximately 0.3. 0.2667 divided by 0.8667. 0.3077. 0.3077. Therefore, we got modulus of elasticity and Poisson's ratio. Little fast I am explaining because there is no too much of concepts here. Just standard formulas are there, or if you study stress strain curve thoroughly, you will understand. Not very high speed I told, little briefly. Okay, now I will remove all this one and go to next part. This all I will remove now. Okay, not required. Continue. Because little more part also I will explain now, so that this is your first part of stress strain. We will close today. Next time we will do new part. Okay, start. Next. They want yield stress. See, 3. You write there. To get yield stress. Y-E-L-D. Yield stress. Our symbol is sigma y, but IS code symbol is Fy. Remember, anyone will do. I will write formula here. Sigma y, yield stress, equal to yield load divided by cross-sectional area. Yield load divided by original cross-sectional area, because it is called engineering stress or true stress. Engineering stress. True stress is something else, because when you reach yield point, diameter will slightly decrease. Then area will also decrease. That all you study in other things. Okay, start. Yield load, they told how much? 28.3 kilonewton divided by area is pi by 4 of 12 square. Therefore, your yield stress, some people call it, or sometimes people call Fy, popular in India is Fy, but as per SOM symbol, sigma y is 28.3 divided by pi divided by 12 square into 4 is into 10 to the power 3. 250.227 Newton per mm square. This is the yield stress. Over. Actually, for mild steel, it is standard 250. Okay, leave it. Next, fourth one. What they want? Ultimate stress. Very simple. To get ultimate stress. Okay. Say sigma u, but IS code symbol is Fu. Make a note. So therefore, remember, sigma u, ultimate stress equal to ultimate load divided by cross-sectional area equal to ultimate load. Set the question. How much given? 46.4. You write there. Given ultimate load is given as 46.4. So 46.4 10 to the power 3 divided by cross-sectional area, original area, pi by 4 of 12 square. 410.266 Newton per mm square is the ultimate stress, that is sigma u or Fu. Okay, now that also over. Now they want Lastly to percentage elongation, percentage reduction in diameter and cross-sectional area. I will do it here now. I forgot the answer now. I require for some reason 250.2 you got sigma y, fu you got 410.266. So there's a reason. I will tell you what is the reason. See, first, percentage elongation. Fourth one. Not fourth one. Fifth one. Correct, fifth one? Yes, correct. Fifth one. To get percentage elongation. Elongation understood at failure. Understood at failure. Or breaking point. Right. That is equal to, that is, so right here, elongation, percentage elongation equal to elongation at failure divided by what? Elongation at failure divided by original length into 100 equal to elongation at failure is how much? Where is it? 40 millimeter. 40 millimeter divided by 150 into 100 equal to 40 by 150 into 100 as per given data 26.667. That's all. Sometimes people write 26.667 percentage. See, I will tell you no. Once you write percentage elongation here, once again percentage you should not write. Like distance from your play home to college in kilometer, distance from your home to college is 5 kilometer, or distance from your home to your college in kilometer equal to 5. You should not tell second time 5 kilometers. So, if you write percentage here, once again percentage not to be done, or you write here, that is the elongation final is 26.667%. Okay. I have seen 99% people, they write percentage elongation, again put percentage here. Not wrong, they will not cut the marks, but looks very odd. Okay, your choice. Okay, now, sixth one, percentage reduction in diameter. To get percentage reduction in diameter, this you should do it. See, directly answer is, see, reduction in diameter is how much? This is homework for you. This is homework for you. Reduction in diameter. See, neck diameter is 8 point. Remember now, original diameter is 12 millimeter. Neck diameter is how much? 8.2 millimeter. Therefore, reduction in diameter is, be careful, don't take 8.2. Reduction in diameter is 12 minus 8.2 equal to 3.8 millimeter. Then you write that is 3.8 by original diameter of 12 into 100 equal to divided by 12 into 100. 31.667. Now you can put percentage because we are not done percentage here. Okay. Lastly, seventh one. Percentage reduction in, not seventh, same thing, and percentage reduction in cross-sectional area. This is purely, I will give homework for you. See, I will briefly explain, you solve. Initial cross-sectional area. Initial cross-sectional area is, you should do it, pi by 4 of 12 square. You should get the answer. You calculate 113.097 mm square. Then, final cross-sectional area equal to pi by 4 of, finally diameter is 8.2. into 8.2 square equal to 52 point. You should do it. See, homework should be solved. 52.810 mm square. Now write, therefore, now you can do easily, therefore, reduction in area equal to 113.097 divided 113.097 minus 52.810 is 60.287. Then write divide by original 113.097 into 100, that will come 53.306% over. Now, lastly, remember, they can ask one thing. I will tell you now. Some exam earlier I have seen it. They will ask you, see, just make a note. They can ask you in the same question or anywhere else, what is allowed stress? Allowed stress with the factor of safety of say 1.8. Now you should know what is factor of safety. I will give a simple example for you to understand. Imagine in your building there is a beam and it is supporting some slab system. Above the beam you want to go for one more floor by constructing a wall. No, floor stopped there. You are thinking of going for further extension. Now, that is, you will go for a wall and then put one more slab and extend it. But it is an existing beam. Before going further, what you should do is, you should check whether extension is safe or not. Maybe you may think of storing some load also there. Some purpose is there for that one. Therefore, you should calculate what is the load coming on the beam from the extra construction. See, what you do? You can calculate that one based on your requirement. Or, in simple language, you first go and ask a structural engineer. I have a beam here for which beam is the best example. Cross section is so and so, reinforcements are so and so. I want to go for a construction, extra construction now. How much more load it can support? The structural engineer, after thoroughly investigating and calculation, he gave the verdict. See, your beam will collapse if your extra load you are applying reaches 10 tons. 10 tons. Okay, ton is better. If you apply extra load of 10 ton on the beam spread over the entire length, beam is going to collapse. Now, you should think, you cannot go for a 10 ton load. Why? Danger. Where is safety? So what you do? You are a person who wants safety. You want to sleep peacefully in the house in the night time. Once in half an hour, should not go upstairs and see what happened to the beam, or tension will come. So you decide. He told 10 ton load if you apply, it will fail. Imagine you need factor of safety of 2 for safer side. Then how much load you will permit? Or if the load permitted is lesser, go for light construction. Don't go for thick walls. Go for hollow bricks like that. Or some arrangement, reduce the weight. He told 10 ton is the load at which the beam will fail. Extra load. Factor of safety of 2. Sometimes students will tell, how much allowed? Sir, 8 tons. No. Factor of safety is a multiplier or dividing number. It is not addition subtraction. Factor of safety of 2 means you want safety margin of 2. Double that way. Therefore, common sense student will tell, therefore, maximum allowed load or permissible load or safe load all are same equal to 10 ton is the failure load, factor of safety of 2 required, divided by 2 equal to 5 tons. So now if you go for an extra construction of 5 tons, it can take up to 10 ton, so safe. Double is the capacity. So factor of safety of 2 means what you have to do? Whatever is the failure load divided by that factor of safety, you get the permissible load. Simple to understand. See, depends on how much factor of safety they give. Now, this question, what is the allowed stress with a factor of safety of 1.8? Now, here problem. One stress is called yield stress. One more stress is called ultimate stress. Doubt will come. Is the factor of safety is to yield stress or ultimate stress? They may not give it. If they give, no problem. So remember, they may not give it. Then you should be very careful. So then understood. Understood, because in all the elastic designs, we apply factor of safety, especially for steel all, based on yield stress. So understood that given factor of safety is with respect to yield stress, that is sigma y or Fy. Already we got Fy, sigma y. We already got, I forgot the value only now, how much you got only, okay, do one thing. See, we already got yield stress sigma y, I think some 250 point something came. I rubbed the board. Now I don't remember the data. I cannot stop the class, go back and see the recording and continue the class. I will do one thing. I will take 250 Newton per mm square. You make a note there. Since it is already rubbed, he does not know the value. He took 250. It came 250 point something came there. Okay, leave that point, 250. Therefore, what? Allowed stress, or you write maximum permissible stress or safe stress with a factor of safety of 1.8 applied to yield stress equal to whatever is the yield stress divided by factor of safety equal to 250 divided by 1.8. Calculate is somewhere there. I do not want to go and pick the calculator and write this much you cannot do, means leave the course, don't come to the class. Over. This is the answer. Write whatever you got. Now make a note. Suppose in the question they tell that factor of safety with respect to yield stress means correct, what you got here. But if they ask you factor of safety with respect to ultimate stress means, you should use that ultimate stress. They will give high factor of safety then, not 1.8. Anyway, in strength of material, if they don't mention, you apply factor of safety for yield stress. Now, if they mention in the question, find allowed stress with a factor of safety of 3 with respect to ultimate stress, then allowed stress equal to ultimate stress sigma u whatever you got divided by the factor of safety, you get the answer. Make a note. Okay. Now, I told about factor of safety also, and remember later sometimes factor of safety you have to multiply also. I will tell you later when you go to column chapter, when you have to divide, when you have to multiply. See, simple example I will give you. I told just now, collapse load for the beam is 10 tons. You want factor of safety of 2. So you are going to allow only 5 ton. How? 10 divided by 2. Now, other way. Suppose you want to go to a tour. Expected expense is say 10,000 rupees. Expected, calculated expense. You want factor of safety of 2. How much money you have to take means nobody will tell 5,000 rupees. See here, how much money you have to take with you means expected expense is 10,000 rupees. Factor of safety of 2. To be safer side, you should take 10,000 into 2, 20,000 rupees. Correct? Or here not that way. Load at which it will collapse is 10 tons. You do not want collapse. You want safety. Factor of safety of 2 means you apply only 5 tons. Whereas if you think expense can come up to 10,000 rupees, but you want to be on safer side, fully safer side, with the factor of safety of 2, you should take 20,000 with you. I will explain that one when if at all I take the column chapter later. I have not decided still. I have still not decided. Even now, what I told earlier, the condition is not satisfied. But I have decided this chapter I am going to complete. This chapter I am going to complete. Then I will decide, shall I continue or not. If I feel you don't deserve it, at least one chapter full I will complete. I decided, no, I do not want to leave halfway through. Only stress strain part, compound members, then what? Lateral strain, then that volumetric strain part, composite members, and tapering bars, or temperature stresses. One part I am going to complete. That is sure. Because I do not want in their uncompleted part, then I am going to stop. Most probably that is what is going to happen. That's why I took a break of 2-3 days now. See, if I wanted to complete everything I told earlier, I would have uploaded class almost daily. Now I almost decided. This chapter, first chapter, one question will come, sufficient for you, for your response. What you, in return to what I told, how you responded, for that, it is more than sufficient, I decided. Let me see, if situation changes, I may cover everything also. Okay, now we will see in next class number 4, we will continue. Okay, thank you.